So today we're doing the law of cosines, and I showed you where the law of sines came from. If you want to see where the law of cosines came from, it'll be in a separate, really short video. And I never want those things that we derive to confuse you and make you think that you have to do that on every problem. But depending on what math classes you take in the future, you may have to do some of those things in some proof type of manner. So it's a good thing to see. I don't ever want it to just be, this is it because I said so. So it's actually derived from the Pythagorean theorem, which is good. That part is good to know because of something we're going to look at here in just a second. But even though I'm not going to show you fully where it came from, we're going to do the first part of what you need to do that with, just because I want to talk about this mathematical thing in general with y'all. It has nothing specific to do with the law of cosines, just how to think mathematically when you're doing stuff. So you don't have to draw it on this triangle. You probably don't want to, because especially since I'm not showing you where it came from, it may, on this, it may confuse things in the future. So basically just kind of use mine up here so that I don't add other things to your triangle. So what we would do is we would start the same way we did for the law of sines, meaning I'm going to draw in the height, just like this. But this time, I actually need to use the pieces that I get down here. So when we did the law of sines, we used the full sides, all of A, all of B, all of C. But this time I need to use these two little pieces. So I want you to think about, and again, it's not a trig thing, it's just how would you label this to get things mathematically. If I labeled this little piece right here, X, then I need something for this piece here that's not Y, but based on what I have there. So I want you to think for a second without speaking, because somebody might have the right answer right now, but I want everybody to have a chance to think. And then if you're not sure, or if you think you have something and it's not right or whatever, I'm going to tell you how you can think through this, because this is actually very simple, and I know you know how to do it. The problem is you overthink things a lot. You try and make things more difficult when they don't need to be, and then that confuses you, okay? Because that's how your little brains work, and that's okay. So instead of overthinking it or not being sure or thinking why is the only thing you could put there, you could always think in terms of numbers, okay? So again, I want you to think without speaking. What if C, the length of C was 10 and X was 3, would you know what this length is? Yeah, you'd be able to come up with it very easily, right? So we don't have 10 and we don't have 3. Instead, we have C and we have X, right? So you're going to do the exact same thing, but you're going to have to do it with C and X. So now somebody tell me what would go right here? C minus X. Okay. Now some of you might have come up with that instantly, but some people don't, not because you're not intelligent, but again, because you're overthinking it or you don't think it's that simple or whatever. But do you see how we just think in terms of, always think in terms of numbers? What would I do if it was a number? Then you do the exact same thing with a variable, okay? So again, that's not specific. That could come up with in anything we do, and I just don't think it gets like focused on enough. So anyway, I just wanted to talk through that part. So now let's talk law of cosines. So the law of cosines can be used to find side and angle measures, just like law of sines was. And this time, if we're given 2 sides in the included angle, which is side, angle, side, or 3 sides, which would be side, side, side. So there's 3 blanks here. I could actually write out 6 different versions of this formula that you would need to know, or you could find in the back of the textbook or whatever. And I really think that those kind of things are not necessary about memorizing 6 formulas. If you understand the concept behind one version of it, you can make all the other ones work. Okay, so we are going to write down 3 different versions so you kind of get the idea of the pattern, but it all just revolves around one thing. And since it comes from the Pythagorean theorem, it looks very much Pythagorean theorem-y, if that's even a word. So it looks like this: a squared equals b squared plus c squared. Okay, now I can't leave it like that because it's not a right triangle, minus 2 times b times c times the cosine of angle A. So write that down, and then we'll talk about how it's really a simple concept here. So remember, this is side, angle, side. So what it's saying is I'm looking for side A. In this case, I would know side B, and I would know side C, and I would know angle A, and that's where your side, angle, side comes from. The letters could be anything. So again, it's more of a concept. it's the side that you're looking for squared. That's equal to the other two sides squared and added together, minus 2 times these two numbers multiplied together, times the cosine of the angle that's opposite that side, right? And once you do it a few times, you realize that that's not really that hard to kind of keep up with where things go. So the other version of this would be like if I was looking for b. So we could have b squared. If it's b squared, then that would be equal to a squared plus c squared minus 2 times a times c times the cosine of angle b. Kind of get the hang of that there? So then I want you to write the c squared version on your own. So do we all agree with that? Easy enough? Okay, good deal. All right, so we're going to find each side length. So this is side angle side, which tells us it's a law of cosines. Now, if you don't remember if it's supposed to be side angle side or angle side angle or whatever, really, if you don't know if you're supposed to use law of sines or law of cosines, if I look at this and let's say I'm trying to use the law of sines, well, I have this angle and the side across from it. The other two sides, I don't know either angle and I can't find them, so I can't use the law of sines. Since I can't use the law of sines, but I have 3 pieces of information, law of cosines is my only other option, right? So to write this down, I take the side that I'm looking for, which is x, and I square it. That's equal to the other two sides squared and added together. Now, whether I put 16 squared plus 28 squared or 28 squared plus 16 squared does not matter, okay? I just take the first one I see. Then it's minus 2, don't forget the 2, times these two numbers multiplied together, 16 times 28, times the cosine of the angle across from x, which is 127. Now, remember, we don't want to really have to do much computation or do anything until hopefully the very last step. Sometimes you want to multiply some numbers or square them, but I don't really need to. I don't really care about x squared. I want x. So if I want x, I'm just going to take the square root of both sides. When I take the square root, it should be plus or minus, but do I care about the minus 1 in this case? No, because it's a side length, doesn't make any sense. So it's a big old square root of 16 squared plus 28 squared minus 2 times 16 times 28 times the cosine of 127. Then I can type it in all at once in the calculator and get my answer. Just make sure you're in degree mode. Make sure if you, whatever calculator you're using, if it doesn't extend that square root over, that you use the parentheses correctly when they pop up, then we should be good, okay? So I'll type mine in. So I'm going to do the square root. And should you know what 16 squared is? Yes. But do you want to make a brain fart kind of a mistake on something? No. Just let the calculator do it since we can. Plus 28 squared. And then that's the number we should get. If you didn't get that number, make sure you double check your numbers. Make sure you didn't forget the 2. Okay, it's kind of a plug and chug type of thing here. Are we all good? And if you're having issues getting the right numbers, please let me know so I can help you figure that out. So we got 39.739 inches. Now, as far as showing your work, I want you to remember that showing your work does not necessarily mean showing every single step possible. I don't know that there's really many more steps I could show because I don't want to actually square that stuff out. But on here, it would be perfectly fine for you to write this first step and then have the answer because I've substituted in, this is what I'm doing with it, this is what the calculator gave me. So on this first one, I wanted you to have this step written down for sure so you know what you're doing. But if you just do this in the calculator but don't write it down, it's fine. You can have this step in your answer and that's enough work, okay? Unless you want to do more, that's always fine too. Any questions at all? All right, so let's do number 3. Number 3, we have to draw it and label it. So I've got triangle ABC. C, measure of angle C is 88 degrees. AC is 22 feet. The length of BC is 11.5. And I'm looking for the length of AB. So you can leave it AB if you want. You can call it X if you want. Just make sure in the end that you answer the question that's being asked and you say AB in the end. So it doesn't really matter what you do as long as you actually answer it in the end. Okay, so you go ahead and set it up. Figure it out. I'll write down the setup in just a second if you want to double check it, but I want you to do it first. Any questions at all? Good enough? And like I said, that's enough work. That's fine, but you can't just have an answer. You have to show some setup in there. It's part of the process. And just, out of habit, I know I would have written down X equals, and that's fine. It's fine that X is there, but just make sure you actually use what it really is in the end and you don't forget your units. Okay? Are we good? All right, so I said at the beginning that we could have written 6 different versions, but I wrote 3. The other 3 would come from when we're finding the angle measure. I just don't find that necessary because you can set this up exactly like we set up the other ones and then just solve for what you need. And having one concept that's tied to something I think is way better than trying to have all these different versions, unless you're just a savant and that kind of stuff, which would be very, very few people. So good for you, but we don't want to know about it. All right, so let's look at number 4. Here I'm not looking for a side length, I'm looking for an angle. So I'm going to use the exact, I still can't use law of sines, so law of cosines is my other option here. Even though I'm not looking for a side length, the side length that I was looking for was tied to the angle I had, so these two things are still tied together. So since that's the angle I'm looking for, this is the side that it has to start with. So that means I'd have 10 squared equals, and then the other 2 squared and added together, 11 squared plus 13 squared, minus 2 times 11 times 13 times the cosine of x. Now, do you know what 10 squared is? I certainly hope so. If it's like super simple like that, if you want to write down 100, knock yourself out. But on anything else, I mean, I don't want you to, have brain farts about anything. So we're just going to kind of leave everything like it is and get x by itself. So I'm going to start by these. So I'm trying to get I need to get cosine of x by itself first. So the first thing I'm going to do is, this is multiplied by it, but these two are added. So I can subtract them both over to the left-hand side, so I can get 10 squared minus 11 squared minus 13 squared equals negative 2 times 11 times 13 times the cosine of x. Okay, and again, I'm going to leave it like that. I don't care what the actual value is. We can do it all at once. Trying to get cosine by itself, so this is all being multiplied, so I can divide it out. That means I can get 10 squared minus 11 squared minus 13 squared all over negative 2 times 11 times 13. That's equal to the cosine of x. So what would I have to do next? The inverse, exactly. So then I would have cosine inverse of 10 squared minus 11 squared minus 13 squared all over negative 2 times 11 times 13 equals x. And then that's when I would go to the calculator. And depending on what if you're using the calculators that make a beautiful fraction for you, it makes it really simple. If you're not, then you may want to, be careful with your parentheses. Make sure you use them in the right places. Sometimes I have overkill on that just because I want to make sure I didn't mess anything up. So I'm going to put my whole numerator in parentheses. 10 squared. I lost myself. Oh, minus 11 squared minus 13 squared. So that's my whole numerator. Then I'm going to divide that by negative, oops, one parentheses. Ugh. Ah! Crap. Okay. Sorry. Cosine inverse 10 squared minus 11 squared minus 13 squared divided by, open parentheses, negative 2 times 11 times 13, and that's it, right? Yeah. Close, close. That should be my answer. Okay, we all get that okay? Whatever method you were using? All right. So then when we write this down as our answer, and we were actually looking for x, and say x equals 48.369. Now think for a second, look at what we have. Do you think that needs a degree sign on it? No, because what happens when you substitute in x? This says x degrees. If I substitute this 48 degrees in here, I'll get degrees squared, and that doesn't make any sense, right? So the nature of how it's asked, there's no degree sign. Now, when we get to number 6, it says find the measure of angle r, then we're going to have a degree sign on it. So even though this is an angle measure, the degree sign's like already there for us. Okay. All right, any questions at all? All right, so then I want you to do number 6, draw a label, get it all done. If you're watching the video, then pause it and come back because I'm going to go take attendance. I'm going to call my angle theta. If you called it x, if you left it r, if you used theta, none of that matters because in the end you got to say it's the measure of angle r anyway. When you're done, check yourself with me, and I want to talk about showing of work on this one. Because there's 4 steps you could show. So bare minimum, because I know some of you want to know what's the bare minimum I got to show. Bare minimum is that you show that you substituted it all in, and then at least one other step. Like I subtracted and divided all in one step. I could have jumped all the way to cosine inverse of this stuff, but I didn't leave myself room and I didn't think about it, so I just had cosine of theta. So even though I didn't show that I was taking the inverse, clearly that's what I did in the calculator, and that's enough. So basically, when you're finding the angle, the setup and at least one more step, whether it's the final step or not, if you need to show more than one to keep it straight in your head, that is absolutely fine. And then in the end, again, make sure that you're actually answering what's being asked and that you have the correct labels on there. Okay? Any questions at all about any of this? Don't be afraid to speak up. Yes? Are you in degree mode? Okay, let me stop the video and then I'll come help you. We'll figure it out. Okay, anything else?